Hey! Hi guys, this is Shipra Ernest and welcome to Code Decode. In this video, we are going to solve another interesting problem. So we are going to solve kth node from middle. You know the drill, we have been given a linked list A of length n and an integer p. You need to find the value of the pth node from the middle towards the beginning of the linked list A. If no such element exists, then we are going to return -1. Without any further ado, let's dive straight into the problem. So this is our linked list. There are 9 nodes present in this particular linked list and our B is given as 3. So we need to find the middle node. In this particular example, 6 is going to be our middle node and we need to return the value from the middle towards the beginning of this linked list. So our output will be the one from the middle towards the beginning of the linked list n nodes. So B is equal to 3. So this is our middle node 1, 2, 3. So we are going to return node 4. How do we approach this problem? The approach is quite simple. Just like earlier problems, we are going to take two pointers named slow and fast pointers and we are going to point them towards our head node. So both our slow and fast pointers have been pointed to node 3, which is our head of the linked list. So we are going to traverse through the entire linked list 3 times. It is B times, and we are only going to move our fast pointer. So our fast pointer will be fast is equal to fast dot next, just like any other problem. Since we are going to traverse through this linked list 3 times, our fast pointer will reach node 11. So now our fast pointer is at node 11. Okay. Once that is done, it's time to move our slow pointer so that we reach the node which we are going to return. In order to do that, we are going to traverse through the linked list once again. While fast is not equal to null and fast dot next is not equal to null, our slow pointer will be slow is equal to slow dot next. So at this moment, my fast is not equal to null and fast dot next is not equal to null. So my slow pointer will move one step forward and my fast pointer will be fast is equal to next dot next. This way we have reached the end of our linked list, and by the time we have reached the end of our linked list, our slow pointer will be at the node which we are going to return. So we are going to return a slow dot value, which is our output. Hope you have understood the approach. I'll explain this approach to you once again. Basically, we're going to traverse through this entire linked list till our fast pointer will be reaching the end of the linked list. And once it reaches the end of our linked list, our slow pointer will be pointing to the node which is our output. In order to traverse through this entire linked list, we are going to take two nodes named slow and fast and we are going to initialize them with value A, which is our head node. I'm going to travel through the linked list B times. So int I is equal to 0, I is less than B, I plus plus. If fast is not equal to null and fast dot next is not equal to null, we are going to try to reach the end of the linked list. Okay, fast is equal to fast dot next dot next. There is a chance that no such element exists, then we are going to return 1. Let's just say in this example, our B value is 10 and our linked list consists of 6 nodes. Once I iterate 10 times, there are only 6 nodes and I'm going to iterate 10 times. At some point, my fast will be equal to null, right? So in such a case, since there is no element present, we are going to return -1. Just like it has been mentioned in our problem statement. Okay, once that is done, I'm going to make sure that my fast pointer reaches the end of the linked list and my slow pointer will return my output. So in order to do that, while fast is not equal to null and fast dot next is not equal to null, slow is equal to slow dot next, fast is equal to fast dot next dot next. By the time we'll be reaching the end of the linked list, the node which is our output. So finally we are going to return slow dot value which will contain our output. Let's run this code once. Okay, the code is working. We have solved this problem using O of n time complexity and O of 1 space complexity. Now there is another way of solving this problem. So in order to do that, we are going to traverse through the entire linked list and come up with the number of nodes present in the list. Count is equal to 9, so there are 9 nodes present. Now we are going to traverse through the entire linked list once again. Count by 2 will be the middle of your linked list, which is going to be this node. Okay, so we are going to traverse through the entire linked list middle minus B times. Okay, which is going to be 2 times. So when we are going to traverse through the linked list middle minus B times, our current will be at node 4, which is our output. Hope you have understood the approach. Let's see the coding part. So I've created a current node and assigned it our head node, and I've also created an integer count and initialized with value 0. This is going to count the number of nodes present in our linked list. Next, we are going to take care of the base case. If a is equal to null, we are going to return -1. While current is not equal to null, I'm going to increment the counter. Current is equal to current dot next, and then I'm going to reinitialize my current variable with the head of the node, since our current variable was at the end of the linked list. And then I'm going to create an integer variable named ans, and I'm going to assign it the value of count by 2 minus b. This ans is what we are going to traverse through the linked list later. And I'm also going to check another base case. If b is greater than count by 2, which means if b is greater than half the number of nodes, then we are going to return -1. Finally, I'm going to traverse through the linked list once again. For int I is equal to 0, I is less than ans I plus plus, current is equal to current dot next. So finally, we are going to reach this node once the iteration is completed. Since it's our output, we are going to return current dot value. Let's run this code once. Alright, the code's working. So we have solved this problem using O of n time complexity and O of 1 space complexity. Hope you understood the approach. If you have any doubts, comment them down below. I'll be more than happy to help you. So yeah, that is it for this video. If you did like it, please don't forget to subscribe to my channel, like the video and share it with your friends. Until next time, bye bye.